I only have one slide left in my notes for this section. I should have, if I'd realized that, finished it in the last video, but it was getting a little long. But just want to conclude with saying, in practice, most people use some sort of technology, either some computer software or calculators and things like that. Most people, because you have large data sets in real life, use computer software, and there's lots of different ones for doing it. Even if you know the math behind it, with software, you can very quickly, very accurately compute your test statistics and your p-values for even very large data sets. Okay? So in real life, that's what happens. So the important thing is that you understand the concept of what the hypothesis is, and then once you get that p-value, how to make that conclusion. Okay? If you have a small p-value, something happened in your sample that was very unlikely if your null hypothesis was true, so you found really good evidence that the null hypothesis is not true. And you would conclude that you can reject the null hypothesis based on a certain significance level, and you have to state what that is. Again, you didn't 100%, you never, unless you look at the entire population, you are never 100% sure. Okay? There's the chance that we're making an error based on random sampling, and that's just what we have to live with. But that's why we want alpha, our significance level, to be really small. And sometimes it's given in a problem. It could be 1%, 10%. Most often, definitely in educational research, and usually I'd say in psychological research and the humanities, social sciences, 5% is going to be the most common. Sometimes 10% if the stakes are not quite as high. If it's a medical field, you probably want it to be much, much lower p-value of like 1% or even less than 1% if you need to be really, really certain of your results. My own personal feelings, now that we're able to compute these things so accurately and quickly with software, is give the actual p-value. That way there's no question, this is the probability, and then the reader can decide, does that convince me or not? Okay? Like if you get 5.1%, that's not really a big difference from 5%, so someone could judge that p-value themselves. Okay? But also on this slide, I'm saying if you don't have access to that software, or if you wonder, how did people do this before we had this type of software? Well, for the z-test, you'd have to compute those z-scores and then go look in the z-tables, like we talked about. There's tables you can go and look these things up. But luckily now, even our handheld calculators can do this. Okay? Apps on your cell phone, I'm sure, could probably do this.